everyone, welcome to physicatube. In this lecture I am going to start the introduction of particle physics. So first of all, what is particle physics? Particle physics is the study of fundamental particles. Fundamental particles means elementary particles. So initially it was thought that electrons, protons and neutrons, which are constituents of atom, they are the fundamental particles of matter. But later on with experiments it has been found that protons and neutrons, they have further structures. Protons and neutrons consist of quarks. So it means that protons and neutrons are not the fundamental particles. Quarks are the actual fundamental particles. So till date we know that electrons and quarks are the fundamental particles in the particle physics. So next is introduction, how the particles have been discovered one by one. So particle physics was born in 1897 with the discovery of electron, when J.J. Thomson was performing his cathode ray scattering experiment, and he has found that streams of particles were actually having negative charge, and he named the particles as electrons. Then from the argument that atom is neutral, so it means there is some positive charge in the atom, and later on in the alpha ray scattering experiment, Rutherford has proved that atom is having a positive charge in the center, that is called nucleus, and protons are present in the nucleus. So after electron and proton, neutrons were discovered by Chadwick in 1932, when it was found that mass of helium is 4 times mass of hydrogen, while hydrogen is having 1 proton and 1 electron, and helium is having 2 protons. Then how mass of helium is 4 times than the mass of hydrogen? So the reason was there is some other neutral particle present in the nucleus whose mass is very similar to the mass of proton, approximately equal to the mass of proton, and Chadwick has given the name neutron to the particle. So neutron is a twin of proton with no charge. And after that, photon was discovered in 1900 when Max Planck was studying the black body spectra, and he has found that the light is quantized, and he has given the name photon to the quantas. So light consists of photons, and later on in 1905 Einstein has confirmed that these photons are particles. So it means light is having two natures, particle nature and wave nature, and from the photoelectric effect Einstein proved that photons are particles which are having energy equal to E is equal to h nu. So after these 4 particles, number of particles have been discovered, and till date there are more than 200 subatomic particles we know, and those particles are not fundamental, means they consist of further simpler particles. Then next, let us divide the particles on the basis of their mass. So leptons are those particles which are having light weight. There are total 12 leptons, electrons, positrons, then muons, their antiparticles, tau leptons and their antiparticles, and corresponding neutrinos. And these, out of these particles, the electrons were discovered first. We know that electrons are having negative charge and they are stable, means they cannot decay further into smaller particles, because those electrons are the fundamental particles actually. So electrons were called the first generation of leptons. So in the first generation of leptons there are 4 particles: electron, positron, electron neutrino and electron antineutrino. Then next is muons. Muons is the second generation of leptons. Muons masses are almost 200 times the mass of electron. Muons are unstable, and lifetime of muon is 2.2 microseconds. So muons can decay into electrons and 2 neutrinos. Muons, in the muon family we have 4 particles: mu positive, mu negative, and their corresponding neutrinos and antineutrinos. At the last slide we will discuss those particles again. And muons are the fermions, means they have spin half. Muons are produced from the cosmic rays. Cosmic rays, when they pass through the atmosphere, the pions that are present in the cosmic rays, they decay into muons. So cosmic rays are the basic source of muons. Next is the tau leptons. Tau leptons are the third generation of leptons. and mass of tau leptons is approximately 3,477 times mass of electron. Again, tau lepton family has 4 leptons, tau negative, tau positive, and corresponding neutrinos and antineutrinos. They are having spin half and they are fermions, and they are also unstable and can decay further into muons and electrons. Means tau leptons can decay into the lighter leptons. Next is the neutrinos. As I have already mentioned neutrino word many times before this. So neutrino concept was given in 1956 when Pauli was analyzing the beta ray spectra. So he found that beta ray spectra is continuous. It means in the beta ray spectra, when neutron converts into proton with the emission of electron, so electron is sharing its energy with some other particle which is having zero charge. So this neutral particle was named as neutrino. That is why its spectra is continuous. Otherwise, if there is only proton and electron produced in the beta decay, then electron should have discrete energy. And till now we know that for every lepton family there are neutrinos and antineutrinos. Neutrinos are the chargeless particles. They are having rest mass 0 and they travel with the speed of light. And we know that there are 3 lepton families and 3 kinds of neutrinos. One associated with electron, one with muon, and third one with tau lepton. So after leptons, the next family is mesons. Mesons means middleweight particles. So Yukawa theory has predicted the existence of mesons in the nucleus. In the nucleus, we know that there are protons and neutrons. So Yukawa said that protons and neutrons, they are exchanging pions with one another. That is why they are feeling the strong forces. After that, many other mesons have been found, and now we know that there are total 8 mesons in the meson family, 3 type of pions, 4 type of kaons, and 1 eta particle. And mesons, pi mesons, basically they are unstable. They can decay into muons. Next, the last family is baryons. Baryons mean heavyweight particles, and protons and neutrons fall in this baryon group. Except this proton and neutron, there are also other baryons which are called hyperons. Hyperons means heavy weight baryons. Means mass of hyperons is greater than mass of proton and mass of neutron. So every baryon is having an antiparticle. Later on we will discuss the concept of antiparticle also. And if we talk about the hyperons, there are 4 types of hyperons. One is lambda, sigma, then xi and omega. And they are again unstable and they decay into 10 raised to power minus 10 seconds. Their mass lies between the mass of neutron and mass of deuteron. Next is strange particles. So strange particles, again, as we have discussed the different kinds of mesons and hyperons, some particles from the baryons and mesons are strange particles because they are having strange quark as one of their constituents. And strange particles were found by Rochester and Butler in 1947 when they were analyzing the data from the cloud chamber, and they found that there is a V-shaped track. It means there was one particle which was decaying further into 2 particles. That particle they named as kaon, K0, and it is decaying into pi negative and pi positive. So strange particles are having some properties that they always produce by strong interactions, means their production time is very small, and they decay via weak interactions, means their decay time is large, very much large as compared to their production time. So second thing is that strange particles, they are produced in pairs. There is when the strange particles produce, there is not a single particle but there is actually 2 particles. So they are produced in pairs and they are unstable, means they can decay. For example, the K mesons in the meson family and all the hyperons. We have discussed about the 4 type of hyperons: sigma hyperons, xi hyperons, omega and lambda. So all the hyperons and all the K mesons are strange particles. Next thing is concept of antiparticle. Each particle has its antiparticle, and antiparticles are not found in normal matter. They arise in the high energy collisions, in the interactions with cosmic rays and radioactive decay. So these 3 are the main sources of production of antiparticles. Antiparticle mass is same as the mass of particle, and they have equal and opposite charge. If we have a particle and one antiparticle, then their charge is equal but the sign is different, sign is opposite. And unstable particle and its antiparticle have same lifetime. If we have one particle that is unstable, means that can decay, then its antiparticle can also decay and lifetime of both is same. There are some neutral particles and their antiparticles are identical, like photon. Antiparticle of photon is photon itself. But there are some other neutral particles which are not identical to their particles, like neutron. Neutron has its antiparticle and that is antineutrino. So now next thing is who and when has given the concept of antiparticle. So antiparticle concept was introduced by Dirac in 1928 when he was studying the electron which was moving at relativistic speed. Then he has derived an equation which was known as Dirac equation, and in this equation there was a problem. So the problem was that energy, which is called the relativistic energy, it is having two values, one is positive and second is negative. You can see in the bottom on the right corner that energy is positive and negative also. So it means that positive energy corresponds to electron. Then what about negative energy? So he has given the concept of antiparticle. He has said that electron is having an antiparticle whose energies are negative, and he has given the name positron to that antiparticle. So he has considered that there is a Dirac sea or a vacuum of negative energy levels and electrons are present in the vacuum, and when one electron leaves its place in the vacuum and it appears in the positive energy state, it leaves a hole behind, and that hole is called positron or antiparticle of electron, which is having same mass as electron but charge of that hole is opposite to the charge of electron. Although this theory is not perfect and now it has been replaced by more advanced quantum field theory, but this was the initial idea of antiparticles. And after Dirac predicted the existence of positrons, that is antiparticle of electron, in 1932 Carl D. Anderson discovered that cosmic rays collisions produced these antiparticles, means positrons, in the cloud chamber. And after that antiprotons and antineutrons were discovered in 1955 in Bavatron experiment. So it means proton and neutron are also having their antiparticle. And next thing, let us discuss about the different kind of forces in nature. As you know that there are four kinds of forces. Already you have studied many times about the forces, but in context of particle physics these forces become important because we know that particles production and decay reactions involve strong forces or weak forces or electromagnetic forces. So these forces are responsible for the decay and production reactions of different particles. So let us have a look on these forces and their properties. So first is strong force. Range of strong force is equal to the size of nucleus, that is 1 Fermi, and strong forces holds the nucleons together, or at the higher energy level we can say that strong forces holds the quarks together because nucleons consist of quarks. And strong forces affect the hadrons. Hadrons means baryons and mesons. And if we talk about the gauge bosons of strong forces, means mediators of the strong forces. So if we say that there are protons and neutrons in the nucleus and then pions exchange between protons and neutrons, means pions are the mediators of strong forces. And if we move to the higher level, means if we say that protons and neutrons consist of quarks, so there are gluons which are the mediators of strong forces on the quark level. So between the quarks the mediators are gluons, and between the protons and neutrons the mediators are pions. Next is the weak nuclear force, which is responsible for beta decay, and we know that range of weak forces is somewhat greater than the range of strong forces. These weak forces affect the leptons only, and mediators of weak forces are W plus minus and Z boson, where W plus minus are the charged mediators and Z bosons are the neutral particles. Next, third thing is the electromagnetic force, and range of electromagnetic force is infinite. It exists between the charged particles, and photons are the mediators of the electromagnetic forces. And fourth, we all know gravitational force. Its range is again infinite, and it affects anything which is having mass, and mediator of gravitational force is graviton. And at the last, let us make a list of all the particles that we have discussed so far. So elementary particles can be divided into two categories. One is fermion, second is boson. Fermions are the particles which are having spin half, means they obey Fermi-Dirac statistics, and bosons are those particles which are having spin integral, means they obey Bose-Einstein statistics. Fermions can be further divided into leptons and baryons. Leptons are the lightweight particles, and baryons are the heavyweight particles. And bosons can be divided into mesons and gauge bosons. And if we have a look on the lepton family, as we already discussed, there are total 12 particles: electron, muon and tauons, and their corresponding neutrinos and antineutrinos. In case of baryons, there are further two classifications. One is nucleons, means in nucleons we are having neutron, proton and their antiparticles, and second is hyperon. In hyperons we are having the heavy baryons, that is sigmas, lambdas, deltas, xi. Xi means cascade particles. Then mesons, there are total 8 mesons, and in case of gauge bosons we are having the mediators that we have already discussed in the previous slide. The gauge bosons are gluons, which are mediators of strong forces, W plus minus and Z bosons, then photons and gravitons. And the baryons and mesons, they collectively are called hadrons because these are the only particles which feel the strong forces. So except these particles, there are also the resonance particles. Resonance particle states are those states which are produced when there is strong interaction between the pions or heavy mesons and the nucleons. So mainly resonance states are the rho meson, omega meson and eta dash meson. So this is all about the basic or fundamentals of particle physics. In the next lecture we will discuss about the eightfold way, that is baryon octet, meson octet and the quark model also. So that is all. I hope you have enjoyed the lecture, and if so, please like and subscribe my channel. Thank you.